Hi everyone, the days came, the new PCBs have arrived, the HW432 footprint looks correct, and the trim pot for the pH sensor has been adjusted as well, that looks correct now as well. So as I promised, I will make a video where I'll try and best explain how to mount the components to the PCB. So, as I said, this is the new PCB, so I will transition straight over to one with some resistors mounted. So this is probably the most important thing, is using the correct resistor values. All the rest is reasonably straightforward. So I've mounted the kickback diodes for the doses, the parastatic pumps. The part number for those is here. I buy everything from RS Components, so that's the RS Component part number, and that's the factory part number. We then have 6 10k resistors and 6 220 ohm resistors. This is all related to the MOSFET circuitry. Working my way up sequentially. We then have a 100 ohm resistor, so that's brown, black, brown, gold, and another 100 ohm resistor here, R13 and R15, that are used for the 2 octo relays. There is an 1.5k resistor here for the first transistor for the ESP8266 enable circuitry, followed by a 430 ohm resistor and a 10k resistor for the adjustable voltage regulator. There is a 240 ohm resistor, red, yellow, brown, gold. Murphy, wait, my dog wants some attention. I have a Zener diode here to protect against reverse polarity protection on the barrel connector if you've wired it incorrectly to your power supply. Part number for that is here as well. Working our way up, we have a 4.7k resistor here and a 10k resistor. These are for the DS18B20 and the DHT22. I then have 4 0 ohm resistors. These resistors here were to have power limiting for the SR401, but I found that it wasn't pulling any power and I'm not really ever using it, so I have always had those 0 ohms. Effectively they're just a jumper, but you can get 0 ohm resistors that are nice and neat. There is then also resistors that I was unsure about if I needed to pull the I2C lines, and I've never had any issues with that because the Arduino does have internal pull-ups. So again, they're 0 ohms. We then have 3 10k resistors for the transistors to control the RGB LED. Now these are the only resistors that you should be adjusting the values of yourself, unless you have electrical knowledge, and I'm the electrical engineer. I pay someone else to do the calculations for me. But essentially these are the RGB resistors, and they will vary depending on what kind of RGB LED you have. I'm using a quite powerful surface mounted Osram Octo RGB LED, and it pulls a lot of power. So that's why it's got the transistor circuitry, and of course you don't want to exceed the maximum 100 milliamps of the Arduino Nano. So for me, I have a 220 ohm, 430 and 220 ohm resistor. The point being is that the RGB is just controlled by the lines being high or low. There is no PMW, so you want to make sure that using your resistor values you can get a nice pure yellow, as well as obviously the red, green and blue. So that is all the resistors on the front. There's 2 on the back. we've got a 560 ohm resistor here. That is green, blue, brown, gold. And then just next to that there is a 10k resistor as well. I believe that's for the LDR circuitry. As I said, the other one's for the E-tape. The 560 being for the E-tape, the 10k being for the LDR. So that's the resistor values, that's the most important part. Now I'll pause the video and mount the next set of components, solder them up, and then go over those changes. So I'll be back shortly.
2 hours later.
Okay, so I've mounted the rest of the components. So let's start off with what I've done. I've added 6 MOSFETs. They are P55NF06 MOSFETs. I've also added the 6 terminal connectors. I've added the HW432 step-up converter. For now I've just added it on some standoffs because this is basically a prototype board. It's the first of these PCBs, so I need to do some testing with it. You could just directly connect that to your board using some of the straight pin connectors. I've added the 6-way dip switch to switch between the MCP 4151 or the 10k potentiometer. Note the orientation of the potentiometer. As you can see, these are just empty 8-socket dills. This will house the MCP 4151, and each one of these will house one of the 2-channel octo relays. I've added the switch. You're going to want to know some part numbers, aren't you? So, rocker switch, again from RS Components. We've got the step-up converter, LM317T. That's accompanied by a 1.5k potentiometer. That's a 1k, sorry. We also have a BC337 transistor and a MOSFET. Let's try and find the part number for that MOSFET. Oh, they would not have the part number on this one. That is a ZVN21. I'll put that in the description to be more precise. Essentially it is just a transistor. Well, yes. We also have the other transistors for the RGB LED, accompanied by a 5-volt passive buzzer. The part number and number for that MOSFET here, or transistor MOSFET, and the 3 here are as follows: VP2106N3. Again, that's the part number. I forgot I had 2 packs of them. They are different outputs. These are rated for 500 milliamps, and this one's rated for 800 milliamps because the ESP uses a bit more current. We also have the fuse holder. Let's try and find that. I've got a whole mess of parts in front of me. The fuse holders. I believe they're called Little Fuse, the company. We also have the output for the SR04 ultrasonic distance sensor. This part number. Again, this is all from RS Components. We also have your standard 2.54 pitch male headers for all these here for the relay outputs. We've got a spare I2C header with these boards, so you can use, or you can just add any I2C devices. You might not want to use the DHC22 and use a different sensor, whatever. We've got the output for the CO2 sensor. Of course, this is for the Arduino Mega Pro. That does just consist of some male connectors. I believe they are 44 row or something close to that. 44 on count, 22 in row. As you can see, I've had to add an extra one to the end, and I cut them in half. I tried filing it down and did scratch my board. Silly me. Shouldn't have done that. We've also got the outputs here. This is for the DHC22, E-tape, LDR, and DS18B20 water temperature sensor. We have again, these are 2.54 pitch. This is a single row, obviously they're double row. This one's for the logic level converter for the display. This row being for the Arduino Nano. This is for the I'm getting names mixed up now. The RTC clock. The name will come back to me in a second. It's embarrassing. We've then got our 4-channel LLC for the ESP here. And then, as I said, we've got the DIL sockets here for the octo relays. Here's the part number, again from RS Components. We've got some single, they're 36 ways, and it doesn't say the back on these. I hate it when they don't know. So yeah, and we've got some barrel connectors. They are whatever suits your need really. I use I believe it's 5mm outer, no 6mm outer and 1.5 inner. I do have a bit of materials on the GitHub page just to clarify those part numbers. It's more about the placement of them that matters in this video. This connector here comes with the TDS sensor, so that's where that comes from, and that obviously connects into there, and the pH sensor. Note you've removed the trim pot from your pH sensor module and replaced it with a 3-pin as seen here. So that will plug in, and then using the dip switch you can use have it set to 1 high, 3 high and 5 high to use the MCP, or 2 high, 4 high and 6 high to use the existing trim pot. And I believe that is all the components I have mounted. So I've gone over the position and orientation of all the parts. I will now add all the parts, actually install the modules, and then I'll add that onto the end of this video. And then I'll be off doing some testing, and the PCBs will be up for sale the same day this video is released on YouTube if all the testing goes well. Alright, cheers for watching, and I'll be back in 5 minutes.
The following day.
Okay, I have now finished testing this PCB, and good news, everything is okay. The HW432 functions perfectly, the potentiometer for the pH board works beautifully, and all the other components hadn't been adjusted but have been tested and work as well. Firing it up, we can see that I've wrote a new version of the Hydro controller, or Hydro Master, version 4.5.1. The main difference with this version is it implements a new RA8875 library that I had wrote myself. The reason being is that the fonts used in the previous RA8875 libraries used a lot of memory, and not only did they use a lot of memory, but the way that they were drawn, their core function, was slightly inefficient. It could be improved in a number of scenarios, but not all. I'll explain that in a second. But if you are to download version 4.5.1, you will need to install the new R8875 9.0 library. Any previous fonts that you want to use with the R8875 library will not work with version 9, and you will either need to manually port the font yourself or create a new one with my font generator tool. Now, as you can see, I've just got, I've left that on for the release, so that's going to be funny. I've left my debug touch just for touch bin coordinates. No matter, I will update the GitHub. I was going to say I've just added this code to GitHub, so I will edit that in a second. So, now why is it sometimes the same speed and why is it other times 50% faster? So if I load up my tool on my computer and we look at a font file, my lovely security tool is scanning it all. So let's pick a nice font. This is the font tool that I've created. It's only supported on Windows, unfortunately, for you Apple users. But if we just pick anything, I like Cabaret Light. We're going to pick a font size. Let's pick something that will fit on the screen properly. And here we could choose from regular, bold, or italic. We'll just leave it at regular. I'll drag this down here. This is what it's produced. Now this is essentially what the R8875 library uses, the fonts in this exact format. As you can see, there's a lot of padding around each font, and this padding is used to align the chars, essentially the glyphs, and the spacing between each char. Now of course there is much more efficient ways to do this, and that's why there is so much memory wasted with these old font files. So what my tool essentially does is it crops the font. So we start it. Now it's a bit slow because I need to optimize it, and the speed, the reason why it's slow is because it's actually doing real-time previews as it goes along. But as we can see, it's removing all those unnecessary, what essentially equates to kilobytes of just empty spaces in the whole font file. Note in mind, most of these fonts are, well, for this font it's probably about 26 pixels in height, even though it's a 22. The chars are actually 22 pixels, but the space in between is more likely probably 32 times by the width, and you shrink it right down, the fonts are almost half the size. So that's the first thing that my new font engine does, is utilizes what I call cropped fonts or compressed fonts. Now this on its own wouldn't work with the old R8875 library because it requires all the chars to be exactly the same height, because it doesn't have any means to align them, nor does it have any means to work out the space between the characters. So with the fonts cropped, that's now saved us a lot of memory, and I had to write a new function to handle these cropped chars. Now secondly, the way that the font algorithm used to work. So let's open up something that will work and something that will, let's open something that will be 50% quicker, like a H. So I drag this over here. This tool, I created an editor so you can add pixels if you wanted to, or resize it and do what you want. But this is the letter H, as you can see. Now, what the old algorithm did was went along the line and found it grouped the pixels together. So if there was a line of, let's say, I'm looking through the camera and my mouse at the same time, it's horrible. Let's say there was a line of 4 pixels in a row. What it essentially does is, instead of drawing them individually, the algorithm would have worked out there's 4 in a row, so 1 pixel high by 4 pixels long on this row, and would have drawn one rectangle to represent that. If it couldn't find it, then it just draws it as it is, but essentially it grouped any consecutive pixels that were beside each other until it hits an empty block or the end of the char's width, and tries to draw them in as least rectangles for that row as possible. Now that's good and efficient, but it can be improved. How can it be improved? Well, let's have a look at this character as it is. So let's say it's gone along and it's gone, oh, well, there's only one pixel, so I'm going to draw one rectangle, or whatever you call it. It uses the rectangle function, so it would draw a 1 pixel by 1 pixel rectangle there. It's gone along, couldn't draw any consecutive ones to group it, and it's got to the end and had to draw another rectangle. Now, what if the function was cleverer and not only looked to its right for the next pixel to see if it could draw them together, but what about if the row below was identical, and the row below that, and the row below that, until it got to the end of the child's height? Then you could essentially say, alright, for this, all we're going to do, now it's not really clever in the sense that it would draw this character could be drawn as 3 rectangles. One for there, one for there, and one for there. But what my code does, it says, look for any matching rows. So in this case, it'd go all the way down to here, and draw that as 1 rectangle, that as 1 rectangle, this is 1 rectangle, and then another and another. So this would be represented as 5 rectangles rather than whatever that is, 6 times 6, so a lot. That's probably, 40 rectangles as to draw there, and mine draws it in 5. Now, sometimes you can't use that functionality. Something might be a completely different width. A V, for instance, that'd be a good scenario. Where are you opening up? Did I click it, or is it hiding somewhere else? No, there it is. So let's say we have this V here. Windows, you do draw, that's exactly how Windows uses it. It's a bit ugly, or did I accidentally click that? Whatever. So, in this case, we can see that there's very few rows that are actually matching. It can still do it in some scenarios. It would probably draw that line, that on its own, then that one, but sometimes each row will not be identical to the row above, so therefore it couldn't group the row below. So now you understand why some characters are drawn a lot faster than others, but they will always be drawn at least as fast as the old version. And with that alone, with my tests of printing out every single character for a group of different fonts, I've got the speed down to draw all 95 fonts from 1.26 seconds to 460 milliseconds. And that means that almost every page on the controller now loads significantly quicker. And I've added a function to the library that actually is called draw XBMP, rather than having to put my icons in a font file to do it. There is still rendering, as you can see. You can still scale the fonts, but everything uses less memory. If I was to look at the code, we've saved 9% in flash memory and 9% in runtime memory. And again, pages draw in under half the speed. If I was to restart it, if you was to notice how quickly it actually draws this existing, the first text, you couldn't even see that happen anymore. You used to see the characters draw out. So it's a vast improvement. But as I said, if you have any fonts, if you're using the RA8875 library for some other projects of your own, and of course you wanted to use my version, which is faster and uses less memory, your old fonts will not work. So you would have to either manually export them. By that I mean you'd go into the font file and compare it to how the new one is written, and adjust it yourself, which is what I did for a group of the old fonts. Or if it's something that's just available on Windows, then you can just go for this list. It's got all the fonts that Windows supports with a preview of all of them. You can set the font size, you create the font, and then you auto crop the font, and then it's created the font file for you. You can manually crop the fonts yourself. If I was to show you, let's just pick something else. Anything, just literally pick something. Let's fire that up. So if you as an experienced user and you've got to use this tool a bit, not only, as I said, can you resize the font, but a right click is to manually crop the fonts. Now you probably never want to do this, and I recommend you don't, but a right click draws a grey square, and that is essentially ignoring it. Now why do I say don't do it yourself? Because I've always been very kind to this tool and made sure I've done a whole row before I click auto crop. If I was to click auto crop right now, with that right there, I have no idea what would happen. So I suggest you just either use the auto crop here for that char, then you click save, or you save yourself some time and just click auto crop all. Why does the tool not do it straight away? Because you may want to adjust the fonts. They're all perfectly rendered. It's probably the best font tool out there. I'm not boasting my own work, but what I mean is most of the other, well, if not all the font tools I've ever used to create fonts for Arduino, they always come up blurry and you have to sit there and adjust them somehow or some other. It means you have to do more than just generate the font. You end up sitting there going through the file and working out why it's not drawn correctly. With this, there's none of that confusing encoding and anything else. You just create the font, click auto crop after you've previewed them, and that's it. It generates the file in the font files. What bugs are there? I've noticed when you do a auto crop that sometimes the preview window for the character doesn't resize correctly. You may be thinking that it's bugged up and you've only got half a character, but when you actually click back on it, you'll see that the whole character is still there. It's just this little preview window that might not resize correctly after an auto crop. So that is the font generator tool. I've added it on GitHub. I've added the latest PCB files on GitHub for this version here. I've also added 18 PCBs on YouTube, and whilst I have perhaps 10 of almost all the components, some of them I only have a couple of. I only have a couple of rocker switches, a couple of HW432s, probably only enough MOSFETs to do 2 other boards. I've got loads of opto relays. I've got a few MCP4 and 5 ones. I've got loads of the MOSFETs. So I've put the description on eBay, but you can buy a bare PCB and you might struggle to find the exact components, so you can just ask me to provide some of the PCB, and I'll do that outside of eBay because it will vary for what you want, and it will just, through PayPal, I'll just say rocker switch is X amount of money plus a fuse holder and whatever else you requested. I may not have them in stock, but I live right next to RS Components and I can get anything in next day or 2 days. So yeah, PCBs are up for sale. I've put the link in the description of this video. If you want extra parts supplied with your PCB, if you're buying one, or if you have your own, you just can't get hold of components, send me a message on eBay and I will sort out a transaction for you and let you know if I have them in stock or if I have to order them. And yeah, everything works really well. The the step-up converter is pretty cool. The pumps absolutely go crazy with an actual 6-volt voltage supply. So yeah, really good news. Everything's working. The code's improved. The PCB's improved. PCBs are for sale. Always hunky dory. Thank you for watching.